Typically, a motor end plate or motor neuron that arises in the brain or spinal cord conducts action potential, which involves sodium and calcium ions, that travels to dozens of skeletal muscle fibers inside a muscle. The events that convert action potential in a muscle fiber to a contraction of the muscle is known as excitation-contraction coupling. An example of this process is a beating heart, which in turn produces a contraction cycle that involves a nicotinic acetylcholine receptor. If you go further inside the muscle fiber, you see that action potential surges through a sarcolemma. Inside the sarcolemma, we have T-tubules that make contact with the calcium ion bearing a sarcoplasmic reticulum. A shape change in the SR opened up dihydropyridine receptors. The calcium ions are released through ranitidine receptors to flood the sarcoplasm. The rapid release of ions that triggers a contraction in the muscle fiber. The T-tubules embed in the sarcolemma around myofibrils, which are myosin, where myosin is also involving actin. The active site on actin is involved on the band of myofibrils. Over thousands of myofibrils are involved in a sarcomere, which contain thick filaments, myosin, and thin filaments, actin. Thin filaments interact with proteins known as troponin and topomyosin. Also involved with the contraction muscle process is the sliding filament theory. This theory starts when a cross bridge is formed from ATP binding to a myosin head. It then hydrolyzes when ATP becomes ADP and lower P. Lower P is kicked off and myosin attaches to actin. ADP is also kicked off, known as when power stroke occurs. Then finally, myosin detaches from actin by adding ATP.